Thank you very much. So good morning, everyone. So that's the title of my talk. Here's the agenda. So I'm going to give a bit introduction where we came to that, explain overall the system architecture and technical approaches chosen, giving some details about the end-to-end chain. I selected a couple of practical considerations, and then I'm going to show a bit the route towards adoption, to the mass adoption of immersive video. So on the intro, well, setting the scene, where did we come to that? There was the launch of the Apple Vision Pro, and there are also other manufacturers which are very eager to bring out their new headsets. So Apple, Meta, Samsung, and Google is also off the part. And well, there was a lot of enthusiasm by professionals, but in fact, the big question was, how can we deliver this experience in live? And on the other hand, there was Focal Point VR, which is a small company which is dealing with immersive since 2017. And we, from ATEM, we were part of the launch ecosystem for the Apple Vision Pro. We had already MHV'26 file encoding, but we could do very quickly live, but at lower resolution. So we joined forces in order to have an end-to-end solution able to do live and live for sports. Yeah, so just to give an overview how this end-to-end system is being built. So first you've got an array of camera. So it's for 8K cameras. Then there's a vision processor by Focal Point VR, which is basically, I'm going to come into details, but stitching and doing the projections. Then it comes to our MHV'26 encoder. To deliver that and encode there, and then you have the alive for the origin, for the live, and it goes to CDN, and then it comes to your homes, for instance, to an Apple Vision Pro on the player, and it's a customized player. So this solution was shown basically in several occasions. So the first one where we had the debut for that, it was in March 2025. So we had some selected customers, and we had a shooting from the Harley Davidson shop. At that time, it was only 25 frames per second. And then we switched to DTG. So at the DTG Summit, people could actually see themselves, basically, because we wanted to show basically the end-to-end, and there was some latency. So I know it's a big topic. In May 25, we did some shooting, some live at the France TV RG Lab, so tennis, as you can imagine. By the way, if you want to have a demo on this, I have it here, so I could show it. And then lastly, what we did in January was horse racing from Ascot, where people could see the horses from the parade. So now a bit more details about the setup. This is a camera array, so 4 8K cameras. And there is the upper ones, which is the left and the right, and then you've got the wide field capture, which is basically giving you the resolution from and the capture from the wider angle. So that comes out with some. Yeah, this setup gives you also the 180, so like this, and the 180 like this. But if you want to you're interested just on the horizontal side, you just need 2 cameras basically, and that's what we did also for Ascot. Then, given the fact that you have 4 SDI outputs per camera, you end up with a very high bit rate. And that's at least what we did with Ascot, is we use some converters to fiber, so that we could also multiplex all to it. And then you end up then with a fiber that you can use for the infrastructure. So here a bit more about the processing details. So in first place, you stitch everything which comes from the camera. And as you know, since there is a wide angle, then this is not just stitching all together randomly. It has a superposition. And then you do the projection, obviously. And then what you do, you apply a mask. So this is the attention-weighted spatial processing. Basically, you look at where basically the most attention is, and then you set that mask, and that's where you have the highest resolution. All the others, of course, peripheral, you lose a bit resolution. And this is then, chopped, let's say, in tiling, so that it ends up into a 2D picture, a rectangular picture, which is easy to encode it to transport. So it uses tiling. And then comes to contribution. So once you have that, you have a signal, a 2D signal, and so either you do some remote contribution, and then SRT is the most practical, at least that we use. 7,680 multiplied by 43 to 20, that's 8K. And as you could see, it's high bit rates, 200 megabits per second. That's what we practice in general. If you would do 8 feeds, at least you need more than 1 gigabit connectivity. That's one of the, let's say, challenges that you have if you want to do multi-view with such things. Another thing that we have also is we have to be very careful about very high variable bit rates. There are some encoders for contributions which have very variable bit rate, and that's really problematic. So best is constant bit rate. On site, you can use directly to feed ST2110 20, but then you have very high bit rates, and that's the challenge, obviously. Or you can use quad 12G SDI here in that case. And what we do generally, for the time being, at least we use SRT, so it makes it easier. But then, of course, you have to decode HEVC stream. That consumes CPU. To my surprise, personally, more than I thought, and especially on a very high resolution. And that you have to take from your overall CPU budget. So then you come to the internal processing before you go to encoding. And you have to handle a high number of bits. So it's 40 gigabits per second. And if you assume 50 frames per second. And all servers and components have to support that. And that's not that trivial. And if you look at this Blackmagic Cine Immersive camera, then you see that it has an even higher resolution. So that's the direction we go. And then it's going to be even more challenging. And when it comes to the compressing, so and the encoding basically, so you compress it to MHV'26. The complexity is closer to 2, so it's below 2. And you end up with 4320 multiplied by 3080/40 per eye. And while here also another note, so that's for the Apple Vision Pro, but if you find a device which can do MHV'26 with big capabilities, then you have to encode with other resolutions. I mean, if you look at blogs in the internet, there are plenty of various resolutions which are supported for other headsets like the Meta, for instance. So in practice, we show that 36 megabits per second is sufficient to have a very good quality. So we can do everything today, but if we go up in resolutions, it's going to be very challenging. I selected a couple of practical things. So about the cameras, a big topic. Where do you put the cameras? How many cameras do you want to put? Or do you switch? Do you have directed cameras? So some people say if you switch too often, like 2D, it's too challenging also. You will feel badly. So rather stay static. We start first also with people saying to us, just one camera is enough. If you want to have multi-view, then you end up with the challenges that you have to scale up all the infrastructure. The other thing is, as for UHD, people want to have basically the same workflow. So that's one of the things. I'm going to accelerate a bit. So one thing is also the eligibility. So you have high bit rates. Not everyone can achieve that. So you have possibilities to do testing connection eligibility, increase the coding efficiency, but there's a limit to that, or adding a lower resolution profile, but that's not recommended, and that's a touch of VR of the last decade. So there's maybe something which needs to be found for that. And then supporting different devices types. We talked about that a couple of minutes ago. So for the time being, you have some limitations. So there are various information about the MHV'26 support. We know it's the direction, but no, we are not yet there. So if you want to support several devices, different devices, you have this challenge. So far there was no request for several multiple devices. And what we need is standardized luminance resolutions. Then, yeah, I'm going to explain a bit what's the roadmap now. So the roadmap is first to break again the boundaries. So go up for the interfaces and decoding with higher resolution, temporal resolution, spatial resolution. And in terms of encoding, in terms also of density. So density is when you are able basically to fit more channels on the same device. Optimizations, multi-device supports, and the latency is also a big topic. And then you have also all these other bits that you can add. And as I said, bitrate eligibility is one thing, and the common workflows for 2D immersive. And some of these things will be addressed now, currently addressed in one of our collaborative projects that we are doing. So it's coding for immersive delivery, rendering and experience. That's the thing that we are currently leading. And now, maybe just to explain a bit, there are some ecosystems considerations. So the first thing is the target customers that we're looking at. So from the traditional media, we can say there's curiosity, but they're rather on the mindset, well, is there any business? Are people willing to pay more for that? I mean, it's the same story as UHD, where they had bad experience. And then there are some sports association which are very interested in this, and they're really serious about this. So baseball, basketball, horse racing, we talked about that, soccer. So that's for the customers. The devices, we talked about that, we still have a device fragmentation. So that's something which hopefully is going to vanish in the future. So if you look at the different sales or devices which I use, then you still see that there is Meta which is leading that, but Meta also has a limited support for MHV'26 currently. So that's a question, how long is it going to take basically to converge? So there is some standardization happening in 3GPP on MHV'26. So this is going to be published soon. So this is a step in the direction of convergence. Yeah, and the last thing is, of course, we want to look at maturing workflows, because we have here a solution which works, but we want this to be interoperable with various people, various stakeholders. And for that also we are members, Focal Point VR and NATEM of the XR Sports Alliance, in order to converge also to workflows and establish workflows. And I think that's it for me.